welcome to Cognos tutorials. So in this video we are trying to learn about the basic history of Cognos and the role of Cognos as a BI tool in data warehouse, and also the basic understanding. We try to have basic understanding of data warehouse. Okay, so let's start with Cognos Analytics. What basically is a Cognos Analytics? So Cognos was an organization which was founded in 1969 in Canada by Alan Rusford and Peter Glenster. It began as a consulting company for the Canadian federal government, and it offered its first software product called Quiz in 1979. However, during the Canadian recession in the year 1980s, Cognos shifted its focus from consulting to software sales. It was originally named as Quasar Systems Limited. However, it adopted the Cognos name in 1982. So the word Cognos basically came in picture as a BI tool or as a tool or as a software services in 1982. Cognos became a public company in August 1986 and it registered in Nasdaq as Cognos. However, its independent existence ended on January 31st, 2008 when Cognos was acquired by IBM. However, in January 2010, Cognos under restructuring in IBM, Cognos basically the reorganization happened of IBM software group, and software from Cognos and recently acquired SPSS were brought together to create a business analytics division in IBM. So this is a brief history of what happened with Cognos. So it was started as an independent organization, and finally it was acquired by IBM, and now it is a part of IBM BI suite. And it is one of the most prominent BI tool in current market scenario. So Cognos BI has various domains. So Cognos BI is one of the arm of Cognos, which is called Business Intelligence and Cognos Analytics. And this arm is basically deal with the analysis of data, that is creation of reports, creation of dashboards, and creation of models. The other arm is called Cognos TM1, which is basically used for the purpose of planning and budgeting, and it is also used for the purpose of creation of cubes which have the write back option. We will try to understand what exactly is the Cognos TM1 in later part of the courses. And the third arm of Cognos is called Cognos Data Manager, which was basically an ETL tool. But as of now, IBM has its own ETL tool called Data Stage. So IBM is no longer supporting Cognos Data Manager. However, there are still a few organizations which are using Cognos Data Manager, but it is a very old ETL tool. Now let's try to understand what basically is a data warehouse and how Cognos is related to a data warehouse. Okay, so these are the points that we are going to cover in data warehouse. So first, try to understand what exactly is a database and how a database is basically different between a data warehouse and what are the things that we are going to do in a database. Okay, so as you know, we have so much of data around us. For example, if you go to a bank, we do a transaction. Suppose we want to open a deposit account. So there may be in the backend multiple things is happening. We as a first of all, our ID will be created, our account ID will be created, our customer name will be created. Then if we deposit some amount in the bank, then how much deposit had been done. So what I mean to say is there are multiple tables are there are multiple so many data is there. However, which data is more useful for us, which is the data which is basically going to give us information which we can analyze for the growth of our organization, which is our bank in our case. So that's where a data warehouse comes in picture. It basically gives us to understand some of our basic questions. For example, if I'm an organization, if I am a CEO of organization, or if I am a manager of organization, then I need to understand which are our highest or lowest margin for customers, or what is the most effective distribution channel, or who are my customer and what products are they buying, what product or options are the biggest impact on the revenue, what impact will new product and services have on revenue and margins? Which are my key customers, and which customer are most likely to go to the competition? So there are multiple questions which we need to answer by using the raw data. So the raw data is basically coming to us from the database, but how we are going to answer these questions by using the raw database? For that we have a data warehouse. So the basic difference between data warehouse and database is like a data warehouse consists of entire information base for all time, whereas a database constitutes real-time information. Another point of difference is like data warehouse supports data mart and business intelligence, where database is used to run business. So let's try to note down all those points. Okay. So what I'm telling is like data warehouse constitute entire information base and database constitute real-time information. So this is the most important thing. Another important thing is like database is used to run the business, whereas data warehouse basically used to understand how we need to run the business. That is the basic functionality of a system is basically done by database. Like for example, I have quoted you example that if you go to a bank and open an account, so in that scenario there are multiple tables needed, like one table for account, one table for customer, another table for say which contains the factual information like how much amount that we have deposited, how much amount that we have withdrawn. So those things basically done with the database. But how to make a proper decision, like how many customers have been allocated to uh, sold by a branch, and what is the most running accounts, most running account types, most running products. So all those things basically deal with data warehouse. Okay. Now let's try to understand what exactly is a data warehouse. So a data warehouse is a single, complete and consistent store of data obtained from a variety of different sources made available to end user in a way that can be understood and used in a business context. Okay. So what happened is like we have multiple systems which we bring together, okay, to create a data warehouse. So let's try to understand this thing by using a small diagram. Okay. So this exactly is our data warehouse. So a data warehouse is like a whole depository of data, and it have its two arms. First arm is called ETL, the another arm is called reporting. So under ETL we have multiple tools like we have data stage or ab initio or data manager, whereas in reporting also we have multiple tools like Cognos BI or business object or crystal reports or Tableau. So we have multiple reporting tools also. Okay, so this as a whole basically give us a picture of data warehouse. Okay, so let's try to understand in detail. So as I told you, it's like a data warehouse is basically consists of a single, complete, consistent store of data obtained from a variety of different sources made available to end users in a way that can be understood and used in a business context. Okay, so here what is the role of ETL? So the whole process of transforming data into information and making it available to user in a timely enough manner to make a difference is called data warehouse. It is a relational and multi-dimensional database management system designed to support or manage decision making. A data warehouse is a copy of transactional data specifically structured for querying and reporting. The technique for assembling and managing data from various sources for the purpose of answering the business questions and thus making decisions that were not previously possible. Okay, but we need to understand what are the key points of data warehouse. Okay, so the key point of data warehouse is It is subject oriented, integrated, time variant, and non-volatile. Now let's try to understand what exactly this term means. So subject oriented means data that gives information about a particular object instead of company's ongoing operations. Okay, for example, like suppose we have a multiple products for a particular organization from which we are generating revenue, but suppose we are not getting revenue from a particular product. So in order to dig in why we are not getting proper revenue from that product, so in that scenario we can deal that thing, we can understand, do such type of analysis you as data warehouse is subject oriented. Now integrated. So what exactly the term means integrated? So integrated is basically like data that is gathered into the data warehouse from a variety of sources and merged into a coherent whole. Okay, so what exactly integrated means? So okay, let's take the case of a bank. So as we know, a bank has multiple businesses. Okay, so a bank can have like multiple businesses, like it have a like ATM, it have a internet banking, it have a like core banking like a normal physical bank. Okay, so we have multiple sources for a particular bank. What that so in order to have a more structured way of data, what we can do is we can bring the data from multiple sources to create a single repository of data in some way like this. So here like we have a single repository, and we have say multiple sources. Say one source could be my internet banking, another sources could be my ATM, another source maybe like my physical bank. Okay, so I in internet banking, then I it can be like my core banking, or then another can be say ATM. So here you can see that we have multiple sources from which we are getting data, and all the sources are basically linked together to create a single repository. So this is what we call as the integrated. Okay, so this is one of the feature of a data warehouse. Now time variant. So all the data, so basically data warehouse is basically mean to is used for the purpose of analysis. Okay, so it contains the historical information. So that's why it is time variant, because it basically helps us to understand data, to make analysis for the data. So all data in the data warehouse is identified with a particular time period. So in data warehouse we have data like instances contain data in historical manner. So we can identify data based on the time period, whether it is yearly data, quarterly data, weekly data, or daily data in this way. And it is done volatile. As I told you, it contains historical data, and unlike database, the data in a data warehouse is not modified in a very regular period. Like it is not like suppose we have created a name of a customer, so we are going to replace the name of customer in this way. That thing doesn't happen. It contains the historical data, and data is not modified very regularly in the data warehouse. So what I mean to say is like data is stable in data warehouse. The more data is added, but data is never removed. We add a row in data warehouse, we can add ample amount of data, but the data is not removed in data warehouse. So this enables management to gain a consistent picture of the business. Okay, and data warehouse is combining data from multiple and unusually varied sources into one comprehensive and easily manipulated database. So common accessing system of data warehouse includes query, analyzing and reporting. Because data warehouse creates one database in the end, the system of sources can be anything you want to be, provided that the system can handle the volume of course. And the final result, however, is a homogeneous data which can be more easily manipulated. Okay, so in this diagram, what we can see is like we have multiple different types of data. One coming from internet banking, another coming from the normal physical bank, another coming from ATM, and we are using a single repository, okay, to create our own reporting system. So that's why we can say that we now after the creation of data warehouse, we have a homogeneous data. So now let's try to understand what is the history of data warehouse. Okay. So the basic concepts of data warehouse dates back to the late 1980s when IBM researcher called Barry Devlin and Paul Murphy developed the business data warehouse. In 1960, General Mills and Dartmouth College in a joint research project developed the term dimensions and facts. So what exactly is a dimension and what exactly is a fact we are going to learn in our next couple of minutes. However, in 1970s, AC Nielsen and IRI provided dimension data mart for retail sales. In 1983, Teradata introduced a database management system specifically designed for decision support. In 1988, Barry Devlin and Paul Murphy published the article "An Architecture for a Business and Information System" in IBM System Journal, where they introduced the term business data warehouse. Now let's try to understand what are the difference between OLAP and OLTP. So you are basically OLTP and OLAP. So these are terms which are going to be used very frequently in a data warehouse. So OLTP is our normal database, like that. It is basically like online. It basically terms online transactional processing. So it basically is like special data organization which access methods and implementation methods for that needed to support data warehouse query. OLTP systems are tuned for known transactions and workloads, while workload is not known as priori in a data warehouse. So actually what happens is in an OLTP system is like, for example, again let's go back to our banking example, or let's take the example of IRCTC, which is very common nowadays. Like so what happens is like whenever we book a ticket, we are basically doing some insertion or updation, or if suppose we book a ticket, or if we modify a ticket, if we say change our boarding session. So in this scenario, what we are doing is we are adding multiple rows or modifying multiple rows in the database. So this is thing that we can do in a OLTP system. Okay, so it is online transaction processing. So it is object oriented. It is used to run the database. It is used to run the business. It contains the detailed data. It is always up to date. Here the data can be modified in regular interval of time or at any point of time. Okay, it normally for AOLTP, like there is no data redundancy. It is basically transactional data. And for OLTP, we have thousands of users. For example, just take the case of IRCTC. We have n number of users. N user can we have. Okay. Whereas a data warehouse or OLAP system, OLAP is basically like a backbone of data warehouse. So as I told you, like OLAP is a subject-oriented, integrated, time-variant, and non-volatile, and it contains the summarized data. It contains the historical data. And since it contains the historical data, therefore it has a very huge volume. Okay, and it doesn't have like so many users. It is basically for the business users who are going to analyze the data to make some proper business decision. Okay, so to summarize, we can say that OLTP is basically used to run a business, whereas a data warehouse helps to optimize the business to make more profit from the business. Now let's try to understand what is the evolution of our organization use of data warehouse and where we are going to exactly use a data warehouse. So organizations generally start off with relatively simple use of data warehouse. However, over time, more sophisticated use of data warehouse evolves. So we have various stages of use of data warehouse which can be distinguished. Okay, so what are those steps or stages of the use of data warehouse that we can distinguish? So the first thing is like offline operational database. Okay, the second is offline data warehouse. The third one is real-time data warehouse. And the finally we have integrated data warehouse. So this is the final and more evolved data warehouse. So let's start with what exactly is the offline operational database. So database in its initial stages are developed by simply copying the data of an operational system to another server, where the processing load of reporting against the copied data does not impact the operational system performance. Okay, so let's understand when in the whole process of creating a data warehouse, the first initial stage is like see, we cannot, data warehouse is a very big repository of data, so we cannot create a data warehouse on a very small thing and a starting position. So for as what happens, like we have already a running OLTP system consisting of different tables joined together. Okay, so that is the initial stage of data warehouse. So here what we are doing is like we are basically taking data from the database itself for the purpose to analyze the data or reporting purposes. So that is the initial phase of the data warehouse or operation database. Now the second phase is like offline data warehouse. So data warehouse at these stages are updated from data in the operation system on a regular basis, and the data warehouse data is stored in a data structure designed to facilitate reporting. So as I told you, is like we cannot create a data warehouse for the starting step itself for a database, and we cannot use data from the data warehouse from the OLTP system or a database directly for the purpose of reporting. So offline data warehouse is something in between, in the initial phase of the creation of the data warehouse, which is used for the sake of creation of reporting. Now real-time data warehouse. So data warehouse at these stages are updated every time an operation system performs a transaction. Okay, that is, for example, whenever we book a ticket or whenever we book create an account or something like this. So okay, so it is okay. It is true that like in old system, whenever we do that, the data is modified. Okay, but whenever new data or some changes happen, so we need to have this information in the data warehouse also itself. So in data warehouse, the data is not updated; it is more like data is appended. Okay, so that we can use this data for the purpose of analysis. And the final phase is integrated data warehouse. So data warehouse at this stage are updated every time an operation system performs a transaction, and the data warehouse then generate the transaction that pass back into the operational system. Okay, so this is the final phase of the integrated of the data warehouse. So in this scenario, like what happened is like we have bring all the data from different type of data sources into system, and we have created a repository data warehouse, and then we have modified all those information in the data, and then we have we are going to use this data for the purpose of reporting. So what I mean to say is like this is how a data warehouse architecture looks like basically. So here you can see that the lower portion which contains the integration. So this is the ETL portion. So here you can see that we are getting data from multiple sources, which can be, so if we go back to our banking example, so we are making, so the source one can be like internet banking, the source 2 can be ATM, the source 3 can be like physical bank. Okay, so we are basically bringing everything from the different sources, and then we are doing some normalization on the data. See, actually we have different types of sources, so each sources have their own tables and columns, have their own set of architecture. Okay, so in the integration scenario or ETL, we are basically doing a normalization of the data. Like in one scenario, like we may have some flag for male and female as say M or F. In another scenario, we can have that as X or Y in this way. So we are normalizing this data and we are creating a uniform metadata. Like it means to say, like we are creating a uniform type of tables and columns. Okay, and finally we are using this structured information for the purpose of query or analysis. So this query and analysis is basically the reporting phase. So here we are basically doing the querying the data to create the reports, which is basically consumed by the clients or business users to make proper business decision. Okay, so what happened is like the data has been selected from various sources and then integrated and stored the data in a single particular format. The data warehouse contain current detailed data, historical detailed data, light and highly summarized data, and metadata. So current and historical data are voluminous because they are stored at the highest level of detail, whereas the lightly and highly summarized data are necessary to save processing time when users request them to readily accessible. Where metadata is like data about data. So what exactly is a metadata? So metadata is basically like, in a very layman term, we can tell that a metadata is like the names of tables, the names of columns are called metadata. Okay. So it is important for designing, constructing, retrieving and controlling the data warehouse. So we have multiple types of metadata. Okay, so let's try to run metadata. Metadata. So metadata is nothing but data about data. So what exactly metadata? So as I told you, like tables, columns, everything, all the details related to data warehouse or related to database, we can call it metadata. It doesn't contain the data. For example, suppose I have an account table. So account table contains a multiple columns like account number, account type, account open date, in this way. So all those column names we can term as metadata, but the content of those columns, that is not metadata, that is a data. So it have multiple types of metadata, like we have technical metadata, business metadata, so technical metadata includes the data that is from where we are getting the data, how the data were changed over the course of time, how the data are organized, how the data are stored, who owns the data, that is who are the business users, who is responsible for the data, that is who is going to make a maintenance of data, who is basically going to append or modify the data, and how we can contact those persons, who are the business users who are going to have access of the data, and what is the date of the last update. So all those things technically related to metadata we call as a technical metadata. Whereas we have business metadata. So business metadata include what data are available, where the data are, what the data means, how to access the data, predefined reports and queries, and how current the data are. Okay. So now let's try to understand what is the business advantages of this whole scenario. So it provides business user with a customer-centric view of the company's heterogeneous data by helping to integrate data from sales, service, manufacturing and distribution and other customer-related business systems. It provides added value to the company's customer by allowing them to access better information when data warehouse is coupled with internet technology. It consolidates data about individual customer and provides a repository of all customer contacts for segmentation, modeling, customer retention, planning, and cross-sales analysis. It removes the barrier among functional area by offering a way to reconcile view from multiple areas and thus providing a look at activities that cross functional lines. It reports on trades across multi-divisional, multinational operating units, including trends and relationships in areas such as merchandising and production planning, etc. Okay, So let's try to understand like what I have told, and by using some business scenarios. For example, let's take the case of a banking. So in banking, what is a strategic use of data warehouse in banking? Okay, so in banking we have multiple functional areas, uh, like we have product development, we have operations, we have marketing. Okay, so how these functional areas are basically going to use data warehouse? So we can use data warehouse for the customer service, for the trend analysis, that is which product is performing well, like how the trend of a particular product in due course of time is, that is this year as compared to previous years or in the last 5 years. Products and service promotions, reduction of reduction of IT expenses. Similarly, in retail, we can use data warehouse in distribution, in marketing. Again, in retail chain also we can use data warehouse in trend analysis. We use it to understand the buying pattern analysis, the pricing policy, the inventory control, the sales promotion, optimal distribution channels. Okay. Similarly, in telecommunication, we use data warehouse in multiple ways, like product development, operations, marketing. That is when a new product is launched, how is the service promotion is happening, how we can reduce the IT budget, how we can understand or we can make analysis for the profitability analysis. So what I mean to say is like data warehouse is basically not for a particular segment, but it can use for multiple domains. It can use in multiple domains, whether it is finance related, or whether it is healthcare related, or whether it is say related retail related, or whether it is a telecommunication related. It can use in multiple ways and in multiple different types of domains. However, do we have any disadvantages of data warehouse? Yes, we do have some disadvantages of data warehouse, and because of this, now the big data is coming in picture. So, data warehouse are not the optimal environment for unstructured data. Okay, the data in a data warehouse is very much structured. As I told you, it's very much structured. For example, here we have one fact table link. It is more like a star schema type. We have where one fact table is linked with multiple dimension tables. Okay, so it is not meant for unstructured data. And because data must be extracted, transformed, and loaded into the data warehouse, there is element of latency in data warehouse. Moreover, over there, live data warehouse can have high cost and maintenance costs are high. That is pretty much obvious. Since we are going to contain such a huge volume of data for the purpose of analysis, because it contains historical data. So whenever new change happens in our normal database, so we need to have all those information in our data warehouse. So in due course of time, this information grows to a great extent. So that's why it is a bit high costly and maintenance costs are high. And moreover, data warehouse can get outdated relatively quickly. So there is a cost of delivering suboptimal information to the organization. Okay, and moreover, there is a fine line between data warehouse and the operational systems. Duplicate, expensive functionality may be developed, or functionality may be developed in the data warehouse that, in retrospect, should have been developed in the operational system, and vice versa. So, because of all those things, what happened in due course of time is that we further normalize data warehouse in various data marts. So, data mart you can say a subset of data warehouse. So you can say that subset of data warehouse, or it is scaled-down version of data warehouse that focuses on a more particular subject area. So a data mart is a subset of organizational data store. Okay, so this is the point that is data mart. So what exactly is a data mart? I have explained what exactly is a data mart, and so data mart are analytical data stores designed to focus on specific business function for a specific community within an organization. Okay, for example, suppose in a banking, we have multiple sources. Okay, we are taking data from multiple sources. We bring a normalcy there. We create we create a uh, repository type of data warehouse, and then depending upon my different departments, so there we have different sources. First we have different sources, now we have different departments, we can say. In a layman term, we have created multiple departments in a data for a data warehouse. So that is basically termed as data marts. So data marts are analytical data sources designed to focus on specific business functions for a specific community within an organization. It is implemented as the first step in proving the usefulness of the technology to solve business problems. Now, why we have created a data mart? We have already created a data warehouse by bringing data from multiple different data sources. Then why we are creating a data mart? We have created data mart for the purpose of easy access of frequently needed data. Okay, so see, suppose what happens, like we have created a data warehouse or repository of data, but it contains a huge volume of tables. So sometimes it may be difficult to make a proper query of the data if we directly access the data warehouse, because it is a huge volume of data. So that's why, in order to make our query easy, because optimization in time is very that is getting data in optimal time is very important to make a proper decision. Otherwise, what difference does this make if we try to query the data and the querying take itself like more than an hour? We need the data instantaneously. So for the purpose, we have created data because it contains small data set, which helps us to make the query of the data pretty easy. Moreover, it creates collective view by a group of users, and it improves end user response time and ease of creation in less time. And another important factor is, like, here the maintenance cost is lower as compared to a full data warehouse. Moreover, here the potential users are clearly more defined than in a full data warehouse, because in full data warehouse we have multiple different types of users using the same repository of data. But if we create a data mart, we can have specific set of users accessing a specific data marts. Okay, so now let's try to understand why we are exactly using the data mart. So data mart, we are using data mart because it is small, it is flexible, it is customized by department, it is OLAP. It is still OLAP. It is still containing the data which we are going to use for the analytics purpose, and it is sourced for departmentally structured data warehouse. Okay. Now let's try to understand data mining. We have understood what is a data mart. Data mart is basically a subset of data warehouse. Now let's try to understand what exactly is the data mining and how we are going to use data mining to support our decision making in the data warehouse. Okay. So data mining is a process of extracting information from the company's various database and reorganizing it for purposes other than what the database were originally intended for. Okay. It provides a mean of extracting previously unknown predictive information from the base of accessible data in data warehouse. Data mining processes is different for different organizations depending upon the nature of data and organization. Data mining tools are sophisticated, automated algorithms to discover hidden pattern, correlation, and relation among organizational data. Data mining tools are used to predict future trends and behaviors, allowing business to make proactive knowledge and driven decisions. For example, for target marketing, data mining can use data on past promotion mailings to identify the target most likely to maximize the return on the company's investment in future mailings. So now let's try to understand what are the characteristics of our data mining tools. Okay. So data mining tools are needed to extract the buried information, which the buried information is like we let's take the buried information as goal. So miner is often an end user who has empowered by data drills and other power query tools to ask ad hoc questions and get answer quickly. with little or no programming skills. Okay, so let's try to understand what exactly I mean by that. So let's take any business scenario. For example, like suppose I have I have a set of data which gives us the revenue for for a particular organization. Okay, for various years and various geographical segment. Okay, but now I want to find out that how much revenue has been generated for Apple, for the sale of Apple Mobile in in say Mumbai segment in year 2000, in year 2019, quarter first, month May. Okay, so here what we are doing is like we have a whole structure of data, and from higher level, that is from year, we are graining down or drilling down to month level, and from organization level also, like from geographical level also, like from the whole geographical level, from to we are drilling down to a city level. So we are basically doing the data mining in such scenario. Okay, and because of the large volume of data, it is sometimes necessary to use parallel processing for data mining. Data mining tools are usually combined with spreadsheets and other end user software development tools, enabling the mined data to be analyzed and processed quickly and easily. Data mining yields five types of information, that is associations, sequences, classifications, clusters, and forecasting. Okay. Starting it rich, which often involves finding unexpected and valuable results. Now let's try to understand what are the common data mining applications. Okay, so one of the most common data mining applications, like where we are making a market segmentation. So there it helps us to identify the common characteristics of customers who buy the same product from the company. In customer churn, like it predicts which customer are likely to leave your company to go to the customer. Fraud detection, it basically identifies which transactions are more likely to be fraudulent. Okay, so for example, like suppose we can understand like there's a normal customer who on a monthly basis do a transaction of maximum say 10,000 or 15,000, and this trend and he has a trend of similar trend like since last 2 or 3 years. But suppose all of a sudden um, uh, money of the order of say 1 crore or 2 crore getting deposited in his account. So there must be some, how come such a huge amount of money deposited deposited in that particular customer's account. So there can be a reason that he has said I'm ancestral property, or it can be a fraud also. So how this type of thing happen? So in such scenario, like to detect the fraud, whether a particular transaction is a fraud or not, in such scenario, the data mining basically comes a picture. Okay. It also used in direct marketing. That is, it identifies which prospects should be included in a mailing list to obtain the highest response data. And it is also used for the market-based analysis to understand what products or services are commonly purchased together. The most important use of data mining is trend analysis. That is, it reveals a difference between a typical customer this month versus last month. We can also use data mining applications in science, where it simulates the nuclear explosion and visualize the quantum physics. And it is also used in entertainment industry, insurance industry, manufacturing industry, medicine industry, oil and gas, and retails. So how data warehouse works with the data mining works. So let's try to understand how basically it works. We have dealt with data warehouse, and we have dealt with data mining works. So let's try to summarize how data mining work with data warehouse. So as I told you, like as we can conclude, data warehouse provides enterprise with a memory because it contains historical data. And data mining provides enterprise with intelligence. Okay. Moreover, data mining is basically used, basically help us in our various decision makings, and the two capabilities that are provided for the new business opportunities are like it helps us in automated prediction of trend and behavior, for example, in targeted marketing, and automated discovery of previously unknown patterns, for example, detecting fraudulent credit card transaction and identifying anomalous data representation, data entry, keying error. And what are the different types of data mining tools that we have? The IT tools and technologies that are used by data miners are like neural computing, which is a machine learning approach, intelligent agents, which is a promising approach to retrieve information from the internet or from internet-based databases, or association analysis, and which is an approach that uses a specialized set of algorithms that sorts through large data sets and expresses statistical rules among items. Okay, so now let's go to the text mining. The text mining is also a type of data mining, and text mining is the application of data mining to non-structured or less structured text files. So it operates with less structured information, and it frequently focuses on document format rather than document content. So how text mining basically helps in? So it helps in finding the hidden content of document, including additional useful relationships. It helps us in relate document across previous unnoticed divisions. If, for example, discover that customer in two different product divisions have the same characteristics or not. It helps us in grouping the document by common theme, that is identifying all the customer, often insurance firms, who have similar complaint or who have cancelled their policies. Okay, so now let's try to understand what exactly is OLAP. So as I told you, like OLAP is a part of data warehouse. So OLAP is basically online analytical processing. This term was coined by E.F. Cord in 1994 when paper contracted by Arbor Software. Okay, and it is generally synonymous with earlier terms such as decision support, business intelligence, executive information system. And in a nutshell, or in a very vague term, we can say that OLAP is like more like a multi-dimensional database. Okay, you can say OLAP is a multi-dimensional database. So online analytical process refers to such end user activity as DSS modeling using spreadsheets, graphics that are done online, and OLAP involves many different data items in complex relationships. The objective of OLAP is to analyze complex relationships and look for pattern, trend, and exceptions. So OLAP is basically like fast analysis for shared multi-dimensional information. Now, what are the strengths of OLAP? So OLAP is basically it basically helps us in giving a huge powerful visualization techniques. It provides fast interactive response time. It is good for analyzing time series, and it can be useful to find some cluster and outliers. Many vendors offer OLAP tools such as Biocom, Cognos, MicroStrategy, and it is possible to access an OLAP database from web. Moreover, the businesses run on information and the knowledge of how to put that information to use. Moreover, this knowledge is not readily, if the knowledge is not readily available, it is continuously constructed from data and information in a process that may not be simple or easy. The transformation of data into knowledge may be accomplished in several ways, and the data collection from various sources stored in simple database. And to summarize, we can say that data can be processed, organized, and stored in a data warehouse and then analyzed by using analytical processing by end user for decision support. Some of the data are converted to information prior to storage in the data warehouse, and some of the data or information can be analyzed to generate knowledge. For example, by using data mining, a process that looks for unknown relationship and patterns in data, knowledge regarding the impact of advertising on a specific group of customers can be generated. This generated knowledge is stored in an organizational knowledge base, a repository of accumulated corporate knowledge and purchase knowledge. The knowledge in the knowledge base can be used to support less experienced end users and to support complex decision making. Both the data and the information at various times during the process and the knowledge derived at the end of the process may need to be presented to users. So how data warehouse helps in decision support? It helps in decision support by putting information technology to help the knowledge worker make faster and better decisions. It is used to manage and control businesses, and since it contains historical data or point in time data, it is optimized to inquiry rather than update. It uses a system which is loosely defined and can be ad hoc, and it is used by managers and end user to understand the business and make proper decisions, proper judgment. Okay, so from this diagram we can understand how business intelligence basically derived from data warehouse. So here from the right side you can see that like we have a raw data and the corporate databases. So we have different types of databases for a particular organization which contains sales, inventory, customer. Okay, and then we have a like a structured data warehouse where all the different databases or different type of data sources are correlated or came in picture. And then in the third tab, we are basically using this data for the purpose of reporting. That is, we analyze the data in tables, we have analyzed the data in graphs, or we have created alerts, and we have this. We have used this data for the purpose of data mining, and finally, we have a end user who is consuming this data. So here we can say that the end user can consume the data both from the data warehouse of from a business analytical tools also. So this is the basic structure of a data warehouse and the role of business intelligence in the data warehouse. So now let's try to understand how business intelligence works. So the process starts with raw data which are usually kept in corporate databases. For example, a national retail chain that sells everything from grills to patio furniture to plastic utensils had data about inventory, customer information, data about past performance, and sales number in various databases. Though all this information may be scattered across multiple systems and may seem unrelated, business intelligence software can be used together. This is done by using a data warehouse. If the data warehouse or data mart tables can be linked and data cubes are formed, for instance, inventory information is linked to sales number and customer databases, allowing for deep analysis of information. Using the business intelligence software, the user can ask or send queries, request ad hoc reports, or conduct any other analysis. For example, deep analysis can be carried out by performing multi-layer queries. Because all the databases are linked, one can search for what product a store has too much of, determine which of this product commonly sell with popular items, basis on previous sales, after planning a promotion to move the excess stock along with the popular product by bundling them together, for example. One can dig deeper to see where this promotion would be most popular and most profitable. The result of the request can be reports, predictions, alerts, and graphical representation. These can be disseminated to decision makers to help them in decision making tasks. Some more advanced applications of business intelligence include outputs such as financial modeling, budgeting, resource allocation, and competitive intelligence. So that's why business intelligence is so important for us, because it helps us or helps a business user to make a proper business decision. So thank you. This is all for this session. In the next session, we will try to understand the basic architecture of Cognos. So before going to that, let me give a small introduction of the Cognos architecture. So Cognos is basically a three-tier architecture which contains like the web server tier, application tier, and the data tier. We will discuss those technologies or terminologies in detail in our next session. So for now, thank you Thank you for now, and thanks for attending the session. Have a great day.